Hi guys, Mr. Star again. What I want to look at today is some two-step equations that we can solve. And, the format that we use is pretty similar to solving one-step equations. We're still trying to perform opposite operations in order to get our variable alone. Again, we're looking for the value that would satisfy these equations and make them true. Now, what's different between a one-step and a two-step? Well, instead of just having one thing to do to get our answer, we'll have two. Now, what you'll look here, let's look at our first example. Again, we can start the same. We split our equation at the equal sign, but we have two things that are kind of blocking our variable from being alone. Notice we have a +2, and normally what we would do is -2. But we also have -3 times x. And how I would handle that is dividing by -3. But it's like, okay, my choices are subtract 2 or divide by -3. Both of those would be appropriate steps. For most two-step equations, we actually do our add-subtract step first. Okay, so between these two, do I want to -2 or divide by -3? I want a -2 first. So let's concentrate on the -2 first. So we'll subtract 2 from both sides. Now, what we've done before is we said, okay, that'll cancel, but notice that I still have a -3x over here. So when I go to rewrite down here, I need to make sure that that is a -3x. Okay, well, let's continue. A little bit of math to do on the other side. -7 minus 2 should give me -9. Equal sign kind of rides the line. And here's like the main difference between one and two step. I still have one thing to do. And if you remember from what we said earlier, my other step was I see -3 times x. Well, what do I do to undo that? Divide by -3 on both sides. And again, this -3 times and this divide by -3 will cancel out. And what I'll be left with is x equals -9 divided by -3, which is +3. And if you just kind of want to check really quick, remember, we can always substitute back in. -3 times 3 is -9. -9 plus 2 is -7. You can always do that to check. Let's take a look here. My choices are -2 or times -3. Well, again, we're going to try and do the add-subtract step first. Why don't we do our -2 first? And we'll go from there. Well, my plus 2 and my -2 will cancel out. So on my left side, I'm left with x over -3 equals 10 minus 2, which is 8. Now I still have one thing to do. I see x divided by -3, so I will do multiply by -3 on both sides. And again, this isn't about -3 times -3. No, that's not what we're looking at here. This is divide by -3 and multiply by -3. And those two things perfectly undo each other. And that'll just leave us with our positive x. Equal sign comes down. 8 times -3 should give me -24. Last but not least, things are kind of switched around here. So I have two choices to make. I see my divide by 2 step that I could take, right? This is 2 times x. So in my brain, I should be thinking, okay, I have a divide by 2 step. And I also have this term that's kind of away from the x, but it's kind of like, things are kind of mixed up in this one. So we have a choice to make. We can either kind of treat this as is, or we can rewrite this kind of in the order that we like. If we did that, that would be +2x. And again, my signs will follow my terms, and that would be -8. So either way, it's going to work here, but I'm going to show you how to treat it as it is. Again, we split at the equal sign. Notice that I always like to work away from the variable first, right? So again, my choices here are divide by 2 or add 8. Well, again, we want to try and do our add-subtract step first. So let's add 8 to both sides. And what are we left with? We're left with +2x. I know it's positive because the plus sign kind of follows it here, but we don't need to write it because when we don't have a sign, that means it's positive. Equals 10 plus 8 is 18. Now I'm one step away from the finish. 2 times x, right? So to undo that, I'll divide by 2 on both sides, and I'll get x equals 9. For our last couple examples here, notice things are kind of flipped around and we have something kind of interesting happening here. All right. So what we could do is we could do what we did before. We could switch things around to get them how they look, or we could treat it as it is. So if I would switch this around, notice this would become negative x over 4, and that's a positive 3, so I need to write plus 3, and I could treat that like that. Now, one little small thing that happens here is, right, this negative is just kind of floating here, and what we have the power to do is we can actually take that negative and put it anywhere in our fraction, right? A smart place to put it would be down here on this denominator, so that, you know, we can kind of handle that naturally later, and you'll see what I mean. So let's treat it as it is. Well, okay, I have a positive 3 that I need to get rid of, or I could kind of have this, I have this multiply step here, but it's kind of weird because I have this minus here, but we'll address that as we go here. We're going to do our add subtract step first. So I need to make a positive 3 go away. I'll subtract 3 from both sides. They'll cancel out, and I'm left with negative 1 over here equals. Now, here's the interesting thing that happens. I need to make sure that I bring this negative down, right? Negative x over 4. I don't want to change the value of what I have left. Now, like I told you up here, a good place to assign this negative would be the denominator, and here's why. When we go to take our next step, or our final step in this case, I can kind of handle the negative along with my last step. Notice that I've turned this into x divided by negative 4. So I need to do the opposite of divide, which is multiply, but by what number? Well, what number am I dividing by? Negative 4. So I will multiply by negative 4. These will cancel out. I'll be left with x equals negative 1 times negative 4, which is positive 4. Kind of a similar thing going on here, right? Whenever I see a variable that doesn't have a number or a coefficient in front, I always like to draw in a 1, just to remind myself that there is something there. However, it's just a 1. Well, my choices are add 2 or divide by negative 1. I'm focusing on the side that has the variable. Well, add 2, we're going to try and do our add subtract step first, so that's kind of the case here. We'll add 2 to both sides. 4 plus 2 is 6 equals, and again, it's all about what's left over. I canceled out this negative 2, but what am I left with? I need to make sure that this minus sign kind of comes down and becomes a part of that next line of my equation, right? I don't want to change the value of stuff. So now this is negative 1x. Well, this is negative 1 times x. How do I solve for that? I divide, right? I see multiply. What do? I do divide. Divide by negative 1, divide by negative 1. 6 divided by negative 1 is negative 6. Equal sign just kind of comes down. These guys will cancel. I'm left with x. Now, I have all of these stars on this last one because, you know, something kind of different happens here. And what we're actually going to have to do, and I hate to inform you, we have to break this rule. All right, on this last one, this is kind of a special case where you're actually doing your multiply or divide step first. And in this case, it's going to be a multiply. So again, we'll start like normal, but notice like there's this big fraction bar just kind of blocking that numerator, right? We can't really get to that numerator until we kind of unblock it from this denominator. Well, I see, remember this fraction bar means division, so how do I undo that? I'm going to multiply. Multiply by negative 2. Now, what's nice about this is these will cancel, and I'm left with x plus 4 equals, and again, some math on the other side, 10 times negative 2 is negative 20. So you can kind of see we kind of went out of order there, but hopefully it kind of makes sense now. That's why we did what we did. Now I have a plus 4. How do I undo that? I minus 4 both sides. X equals negative 20 minus 4, and you'll land at negative 24. So again, guys, 6 very different examples there, all around the idea of solving two-step equations. And there are so many forms that two-step equations can take. So this was just kind of like a little sample of everything you should see. Now, this isn't everything, obviously, but hopefully this gets you on the right track. That's all I have for you today in this one, guys. We'll talk to you in the next one.